Hello, everyone. Welcome to Cloud Native Live, where we dive into the code behind Cloud Native. I'm Annie Talmaster, and I'm a CNCF ambassador as well as a senior product marketing manager at Camunda, and I will be your host tonight. So, every week we bring a new set of presenters to showcase how to work with cloud native technologies. They will build things, they will break things, and they will answer all of your questions. So, join us every Wednesday to watch live. So this week we have a really great session on locking down your cluster. Really excited for that, which is really great. And as always, as a kind of like a housekeeping item, this is an official live stream of the CNCF, and as such, it is subject to CNCF Code of Conduct. So please do not add anything to the chat or questions that would be in violation of that Code of Conduct. So basically, please be respectful of all of your fellow participants as well as presenters. So with that matter handled, I'll hand it over to the speaker to kick off today's presentation.
Thank you very much, Annie, for the intro. My name is Alejandro Pedraza. I work with Buoyant, the makers of Linkerd. I work as one of the maintainers of this open source project. And today I'm happy to talk to you about Linkerd's implementation of mutual TLS and how we leverage the authentication that mutual TLS gives us to implement traffic policy. All right. So these are some of my social media accounts. If you want to hit me with questions after the presentation, I would be very glad to answer them. But if you do use Linkerd or you are in the project, I really recommend that you join our Slack channel. Questions go unanswered usually there, the maintainers or by the community itself. So please head to linkerd.io under the community section, and you will find there the link to Slack. So that's that. So first, I'm going to show you a couple of slides just to make sure we're on the same page about a couple of concepts. Then most of the time will be spent on applying all these things. So mTLS, for that, I'd like to first talk about TLS gives us guarantees that we can remember using the CIA acronym. So first, confidentiality, that means that connections are encrypted. So if anyone is listening to the data, if they can see the packets, they won't be able to. Secondly, integrity, that means that we have the guarantee whatever we get is, we have the guarantee that it is exactly what we get, what we receive. And finally, authenticity, which is what we are most interested in today, means that the served person on the other end can prove who they claim they are.
Yeah, there seems to be a bit of audio issues. If you can do anything from your side, that would be nice. But I also advise all the attendees, sometimes I think there is a bit of audio issues that gets worse if you have multiple tabs open, for example, or you're using your bandwidth of your browser, for example, quite a lot. So I do recommend trying out those kind of fixes as well, or refreshing your page and so forth. That's always a good thing to do. But obviously, I can at least hear what you're saying, so we can continue as well. But if there's anything that you can do super quickly, you can look into that.
How does it sound now? Is it better?
I think it's clear. It sounds a bit further away, but I think it might be clearer. Yeah.
Okay. Let me try something wilder.
Yeah.
Okay. How about now? Much better in theory?
I think this is it's a bit different. We can just go with whatever you felt the best, and we can see there's some people saying that it works okay. At least my voice is working quite okay, but we can try out something and okay, there's a few comments, but at least I was able to hear
Okay.
Quite okay, so we can see.
All right, I'll go on then. So I was talking about TLS, confidentiality, integrity, authenticity. So there's an asterisk next to authenticity because usually TLS only cares about the authentication of one side of the connection. So most people are familiar with TLS in the context of web browsing, where the server presents a certificate that proves who that company or that person behind that person is, behind that page is. And if usually the server doesn't care about the identity of the client, and if they do, they implement that higher up the stack at the level of the application layer through things like login forms or things like that. So in the context of microservices in clusters, we are interested in both identities, client side and server side. So for that, we use mTLS, which is nothing more than TLS with authentication on both sides of the connection. And what certificates certify? It's just a subject in the case of microservices. In the case of Linkerd's mTLS implementation, our identity is tied to the service account of each one of the workloads that are getting mTLS. It's not exactly the service account, it contains the service account, but we will see in the demo exactly how that string looks like. There are some concerns around mTLS. For example, why do we have to implement this at the perimeter of each pod, and why not instead at the level of the host or at the cluster itself as a whole? Well, even though if we are, we might not have total control of what runs in our clusters, for example, regarding dependencies. So that's one vector where people can get into our cluster and start communicating with other pods that they're not supposed to. And ideally, we should secure things at the most granular level as possible. And this is, in a few words, what the zero trust philosophy is all about. There's also a performance concern. It is true that mTLS entails an additional handshake, but that only happens at the beginning, at the establishment of the session. Also, there's some CPU resource consumption whenever we have to decrypt incoming data and encrypt outgoing data. But really, that's in practice negligible, and it's worth the price given the additional security we get out of this. But the most important concern is that it's really, really hard to implement this well. In particular, what regards the certificate management, there are multiple layers or certificates that you have to handle. There's the issue of distributing these certificates across all the cluster, and also you have to renew these certificates as often as possible. Thankfully, Linkerd gives you all of this automatically. I think one of the principal reasons why people start getting into service mesh in production is this, just to have mTLS implemented without too much pain. And in Linkerd's specific case, we implement this through a three-layer hierarchical model of certificates. First, we have a trust root, CA, which it is used to issue another certificate that we call the issuer certificate, that is used by the Linkerd identity component, and it is using this certificate that we sign all the certificates that get distributed to each one of the pods that require it. These certificates that the pods received are short-lived. They only live for 24 hours, and they are automatically renewed by the proxies. So let me really quick summarize how the Linkerd proxy injection works. Whenever a new pod starts, the first thing that happens is there's a webhook that is called. That's the Linkerd proxy injector component. It injects the proxy inside the pod, and it as a sidecar. It does so that it is first the proxy that starts. The first thing that the proxy does is send the Linkerd identity component the service account token that proves that this particular workload is associated to that service account. Then the Linkerd identity component checks that against the kube API and then returns the short-lived certificate to the pod. And when the proxy finishes doing this, then the main container can start, so that it has a guarantee that at the start, any incoming or outgoing connection is going to be encrypted. If you want to try this by yourself, it requires zero configuration. If you try it through our CLI tool, by default, it's going to create the trust root and the issuer certificates. There's nothing you have to do to start playing with this. In production, by contrast, we don't recommend using the CLI, even though there are people that are successful doing that because it offers you all the features. But instead of that, we recommend using the Helm charts. The functions in the Helm charts don't allow us to create certificates using the elliptic curve algorithm. So that's why we cannot provide these certificates by default. But anyways, in production, it is always advisable that you yourself take care of these certificates, in particular the trust root and the issuer certificates, and you provide them to Linkerd. Or what a lot of people do is delegate that to something else like Cert Manager that automatically creates and renovates and rotates those certificates, and Linkerd provides a nice integration with them. Okay, so how are things so far? Okay, better time.
We got as you can see, everyone said that the audio is a lot better, so it's all good on that front.
Great. All right.
Oh, there's a question. How does
Sure.
certificate rotation affect existing communication?
Okay, great question.
And oh, by the way, we can see the Restream Studio right now on the live feed.
Okay.
No worries.
Let me move that to the other screen. Okay. How it doesn't affect the communications at all. I'm not aware exactly of the implementation on the proxy side of things, but as far as I know, it doesn't stop communication or add any latency at all. It's all rolled out seamlessly. So that mTLS deals with authentication. That's just one side of the security coin. The other side is what can we do once we know that a client is who they claim they are. So this is authorization. What is this identity allowed to do? We do this in Linkerd through authorization policy that we started shipping on our latest stable version. That's 2.11 that we shipped a couple of months ago. This is similar in intent to what network policy offers, which is a native Kubernetes resource. Network policy, in a few words, lets you declare which pods can communicate with what other pods, given their network identities. So that's just basically IPs. You are also able to select pods through label selectors. But Linkerd, instead of that, uses workloads identity, which is a higher abstraction that is much more expressive and lets you do things a little more on the app level of things. So we're going to see concrete examples in the demo. It is important to keep in mind that this policy is applied and verified on the inbound side of pods. So a pod will consult these policies whenever a incoming connection comes in, not on the outgoing side. So this will come later in the next stable version, but I think we can agree that most importantly, the policy on the server side is what matters most. This particular implementation will give you these tools to work with these. First, there's a default policy, which is simply an annotation that you can put on the namespace level or at each workload level. Similarly to network policy, you can say, for example, that the default policy is to deny all connections. So you would lock down all the connections inside your namespace. And then on a case-by-case basis, you can override that policy. And then we declare a couple of custom resource definitions. First is server, that allows us to select what pods we're interested in, what workloads, and what ports and protocols we want. And server authorization, which is actually the rules themselves and to what servers they apply. So for example, you only want to receive connections on some port that uses gRPC and only coming from some other workloads that are identified through some specific particular way, or you may allow all incoming traffic, etc., etc. So we will see detailed examples in a moment. So now I'm going to move to a demo. First, I'm going to talk a little bit about how we deal with mTLS, and then we will see an example of authorization policy in action.
Perfect.
In the particular
question here, there's a few follow-up questions after that. Do you want to take them now, or do you want to take them at the end of the a whole session?
Let's take one or two now. I think that would be fine.
Great. So there was another one that if we are talking about cert, what is the good way to secure those? And thank you so much, everyone, by the way, for the questions so far.
How to secure the certificates? Well, for example, if you are installing Linkerd with the trust root that you create yourself, Linkerd only requires the public key. That actually is stored in a config map. It doesn't require any particular security because that's public. The key, Linkerd doesn't require the key, so you should store it securely outside your cluster. The issuer key, the issuer certificate, which derives from that root, on the other hand, it is stored as a secret in your cluster. It's both the public key and the private key. We will see specific examples in a moment, but yeah, they're just stored as secret, and the best policy is to rotate them as often as you can to avoid any problems.
Perfect. Should we take? Okay, there's 3 more questions that has come in. Do you want to take one now, or do you want to leave them to the end of the presentation?
Let's leave those others till the end, and we can go ahead with the demo so we can land more concrete examples.
Yeah, but keep the questions coming. We can get them to the end. So, but yeah, let's go to the demo.
Okay, and in the demo, we will see a specific example of how to isolate namespaces, which is a common use case, which means that you only allow traffic from within the namespace, and anything coming from outside the namespace is denied. So let's jump into that. Right, so here I have a cluster, MP cluster in my local laptop, and we're going first and foremost install Linkerd. So it's very simple. Linkerd install gives us back just the YAML for the Linkerd resources. So we send that, we pipe that to control. We're also going to use Linkerd's V's extension, which provides with visibility that we will use in a moment. But keep in mind that that is not needed to implement mTLS. This is just, it gives us some extra visibility. Okay, and As I said, by default, this is going to create some root certificate and an issuer certificate and install it in our Linkerd installation. So let's take a peek at those specific certificates. As I just said, the trust root, it's only the public key, so it is stored as a config map. So let's take a look at it. Okay, so there we have it, the bundled certificate. We can inspect it closer. So we'll do some JQ magic here. So we want the data field and CA bundle. Oops. Cert. And we want to get rid of the wrapping quotes. I did a mistake there. I think I missed here. Quote. Oh, what's going on here? Sorry, I need JSON here. Okay, finally, that's the certificate. I need to get rid of the line feeds. There it is, and I send that to Step, which is a tool similar to OpenSSL, but easier to use. All right, so this is our certificate. First thing we see is that it lasts for a full year starting now. This is the subject of the certificate, very simple. And most importantly, it is a CA, so it is able to sign and create other derivative certificates, which is what Linkerd does during its installation. It created the issuer certificate that derives from this one. So let's take a look at that one. This one, on the other hand, since it is both the public key and the private key, it gets stored as a secret. We need the private key so that it can itself create all the certificates for the pods. So that's stored under the identity issuer. Let's see. Okay, there we go. Better, yeah. YAML. There it is, our public key. The identity issuer. Sorry, yeah, the public key over there, the private key here. Let's inspect again that public key. Okay, that looks good. This is base 64 encoded, so we decode it here. There's our certificate, and we inspect it with Step. Okay, this certificate also lasts for a year. It has the same subject as our trust root, and it is also able to generate other certificates below it. Okay, so now let's get back to our cluster and let's install a sample app, which is Emoji Bottle. It's something that we always use for Linkerd demos. Okay, let's take a quick peek at what it does. So these are the services that it exposes. Let's pull forward the web front end. Okay, and this here. Okay, this is a fun app that lets you vote for emojis. You can pick as many as you want, view the leaderboard, and there's some bot that is automatically voting, so we have some sample traffic that we can look at. All right. So what's next?
Okay, I'm going to create a debug pod that will let us, let's say, a privileged pod that will allow us to inspect the traffic inside the host as a whole. So we can see what this app is doing. This is the node. I'm using an image that I know that has TCP DOM. Next sheet. Right, just give me a moment. Okay. So I'm going to inspect whatever comes through all the networking interfaces. I want to see any GET requests. If I pause this for a moment, you can see all these requests on plain text, so nothing is encrypted yet. These are the requests that are originating in our bot. So it's this pod here. It communicates with our web frontend, and that web frontend communicates with the emoji component, which returns all the emojis that are available, and the voting component, which actually persists the votings. Okay, so let's leave this here running on the bottom. Okay, and now I'm going to inject this app, Emoji Bottle. Let's do that in a separate window. So I just retrieve the YAML of all the deployments inside that namespace. Get deploy YAML, yes, and I pipe that into Linkerd inject. The only thing that Linkerd inject does is add an annotation so that when the pod gets created, the webhook that gets called, that's a Linkerd proxy injector, will see that annotation and it will inject the proxy as a sidecar. And let's pipe that into the cluster. Okay. Okay, we can see now that as the pods get rolled out, we see two containers per pod. So one is the main container, the other one is the proxy that just got injected. And okay, let's take a look at. Okay, yes, here we're still sniffing the traffic in the host. We no longer see that much traffic because there are no longer GET requests that are out in plain text. We still see things like these health checks that are coming from the kubelet, because the kubelet doesn't run inside a pod. So there's really no way to inject a proxy there, but I think that's fine. So we just achieved mTLS to this app. Okay, how else can we make sure that all these connections are secure? There's this tab command that will inspect. I'm gonna shut this down here. That inspects in real time. It gives us examples of everything that goes through some specific pod. For example, here the web deployment. So it shows us some of the headers, and it guarantees us here that the connection is encrypted. We also can take a look at Linkerd's this dashboard. Here. Okay, so we're interested in the emoji photo namespace. And let's see the web deployment. So here are the incoming connections, the outgoing connections. Here at the bottom, we see everything that comes in and comes out, the identity of each one of those connections, and whether they're secured or not. So here, they're all secure. Okay. Let's see. Okay, let's take a peek at one of those pods. again, web, for example. So what can we see here? First, the first container we see is the proxy, which gets injected before the main container. We see that the proxy has access to the certificate through an environment variable. That is the trust root certificate. Since all of the certificates in the cluster are rooted at the trust root, we need the trust root here in order to validate that those certificates from the connections that come into the pod. And also of note here is a volume linkerd and entity, identity and entity. Okay. We see this volume here that gets injected by the proxy injector. It is a memory volume, and that's where the proxy stores its certificate. It's a 24-hour certificate. It doesn't store it in the file system, so in case there's a security breach or anything, or there's a rogue process running the host, it doesn't have access to the file system and see the actual certificate, along with its private key, of course. So there's no way to directly inspect that certificate like we did with the trust root and the issuer certificate, but there's a command here, linkerd identity. So we are interested in emoji voto, a namespace, and the web deployment. Okay, that's not it. Actually have to issue the entire name of the pod. There we go. So we see here the subject of the certificate. So this is the workload identity that we mentioned many times before. The service account of this pod is called web. I forgot to show you when we saw the pod YAML. And then it's the namespace, and everything that comes is the same everywhere. We have cluster local at the end, which is the cluster domain. By default, it's cluster local, but it can be anything. So one thing to remember is that all the workloads in this namespace will share this suffix. And here the prefix will be their service account, which usually changes amongst workloads. This certificate is not CA, so it's just a leaf certificate, and it can be used for TLS authentication. Okay. Right, so let's dive into policy. Okay, I'm going to start telling the log of the bot just to make sure that it's working properly. Okay, so all this means that it is able to successfully send these requests for these votes. And now I'm going to annotate the emoji voter namespace with a default policy of deny, so we can log deny all the connections inside the cluster, inside the namespace. So I'm going to copy that command actually. There we go. So the default policy is going to be denied for the entire namespace. This will only apply for new pods. It doesn't apply for the current ones, so we will have to roll them. For example, let's roll out the web pod. So I'm just going to delete it. And we can see that both pod starts failing because its connection is getting denied now. Okay. And another important thing here is that actually the web pod is not able to start fully. Only one container is running. So let's take a look what's going on here in a separate window. Let's describe web. And we can see here the problem is that the readiness and the liveness probes are failing. That's because we haven't granted access to the connections coming from the kubelet. So let's do that first. For that, I'm going to use this policy here. Where am I? Okay, so this is our first CR server that says that this applies to all the pods that have a port called linkerdadmin that uses the HTTP protocol. So this happens to be the proxy endpoints that take care of serving the probes. And we want to give, well, we create here the server authorization, which it is tied to that server, which is called admin. And the rule is just to let in everything. So that's an authenticated true. It means that everything that comes in is allowed. So I think that's fine for probes. So let's apply that. Okay. And we can check that the authorization was actually persisted. So there's this command linkerd auth returns a server resource called admin that is tied to an admin everyone authorization. Okay, and now we see that the web pod is able to successfully run. We are still not, the bot is still not able to communicate with it because we haven't rolled everything up yet. So let's do that. So let's call deploy. Okay, let's give it a moment. Oh, actually, I forgot. Yes, this is not going to work yet because we only allow traffic for the probes. We need to actually allow traffic for the actual app connections. So there's this other policy, app policy here. So we have this server resource which deals with gRPC connections here. So the port, anything that has a port named gRPC and that uses the gRPC protocol applies to this. In our case, that's the emoji and the voting pods. Then we have another one here that deals with HTTP connections. That's only relevant to the web component. And finally, a server authorization that is tied to all the servers above, because all the servers above use this label here, emoji photo authority. And the actual rule is to allow all the traffic whose identity matches this, which is all the workloads, all the service accounts that live inside this namespace. As I told you before, they all share this same suffix. All right, so let's persist that. And now let's roll out again. And I'm going to tail the both bots logs again. And this time it is working fine. So all the traffic within the namespace is working. Now let's make sure that any traffic coming from outside the namespace is denied. So for that, I'm going to install a parallel emoji photo instance, but on a separate namespace. So for that, I use some seed magic. Okay, So what this command does is it calls the same YAML we used before, but it replaces the namespace with emojiboto2. That's all it does. So we can see it here getting started. Let's take a look at you can see on the top here, the bot still works because this is the old bot running on the emojiboto namespace. We should instead take a look at the one running on emojiboto 2 now. And it is not working. Actually, so that bot on emojiboto 2 is not communicating with the web pod on emojiboto 2, but on emojiboto. You can verify that checking its YAML here, pod bot. So there's a special environment variable here, web host, that indicates where it should direct its connections. So we didn't replace this when we install this, so it's still pointing to the old namespace, and that's why it is getting its connections denied. And okay, 1 second. We can check those denials directly on the server side. So that's on the web pod. We're going to tell the what's going on here, logs. The proxies logs. You can see here the denials. So we see that the failing request is coming from this identity. Turns out the vote bot service accounts is just the default one. And we can see the IP where this is coming. So this is .42. So let me verify that. Second. So it said what? 42. I'm lost in my windows. 42, this one. So yeah, that's the vote bot on emojiboto 2. Okay. So this is all the visibility you get by default to catch all these denied services. Buoyant does offer this SaaS offering called Buoyant Cloud, which gives you a more detailed report on all these. You can set up alarms, notifications to email, Slack, or whatever, whenever one of these policies gets violated. Okay. All right, yes, so let's get back to the presentation. Just a moment. Where's my window here? Okay. So all the second part in specific that I just demonstrated, you can follow that again in the blog post that I posted in the Buoyant blog. I'm going to paste the URL in a moment. I just mentioned about Buoyant Cloud. Besides that, those extra alarms notifications that you get, you can also more easily manage certificates, and you get a host of other nice features. And as a bonus, you get full Linkerd support. So if you haven't yet and you are interested in using Linkerd in production, I recommend that you ask for a demo at buoyant.io/demo. Okay, I think that's all I have for today. You can go on with questions.
Perfect. A really great session and demo. Always amazing to hear about Linkerd. So then to the questions from the audience. Kick it off with the ones that were asked in the beginning, and let's see if we have any more coming in. Excuse me, my voice is a bit wonky today. So there was a question about does this setup take care of the root CA verification, or is it limited to the network comms?
Root CA certification. Sorry, where is that question? I don't understand that fully.
It was from LinkedIn.
Okay.
About during when we were talking about the first question or the two first questions, but if it's kind of
So is it limited to the network communication?
or if the user is still listening in, you can clarify the question and you can answer it a bit later.
So you are guaranteed here is that when you receive a connection from another pod, its workload identity is what it claims it is, and we use the root certificate to validate that, because all the certificates of the pods are rooted at the trust root. Not sure if that answers the question.
Great. If you want more clarification, LinkedIn user, just send another question in and we'll get to it soon. Great so far, no worries. So another one from Sundar. Authorization policy. How do you relate this to Auth2 and the identity management with tools like Keycloak?
Okay, yeah, I'm not familiar with Keycloak. In Linkerd, we limit ourselves again to workload identities. I don't know if Keycloak can be configured to use service accounts as identities. If it is, then I guess it would work fine.
Great, and I think there was a clarification. So the assumption is that the root cert is automatically trusted.
Yeah, that's where the where the trust is rooted at, as the name implies. So yeah, if your root certificate is compromised, there's nothing you can do. So that's why the first thing you have to avoid is storing the key anywhere inside your cluster, the private key.
Great. And then there was the last audience question so far. Which way do you prefer? One certificate for all workload or one for each segment? And what kind of trade-off do you think you'll have, given that we have auto-renew capability?
Mm-hmm. We do issue one issuer certificate per cluster. In the specific scenario of multi-cluster, each cluster would have separate issuers, but they have to be rooted at the same trust root so that they can both clusters communicate. So that's really all the segmentation. Yeah, that's it.
Great. And then I think there was a continuation from the authorization policy question. So if ignoring Keycloak, how do you do role-based access control in Linkerd?
Mm-hmm. Linkerd doesn't offer anything specific to RBAC. It just relies on whatever you set up with Kubernetes. Yeah, one of the goals of Linkerd is to try to leverage as much as possible the Kubernetes primitives without trying to invent so many things on top of it. So RBAC would just work as it should. Yeah, mTLS and authorization policy is really separate from RBAC because this is really at the application level. RBAC is more lets you define what you can do against the Kubernetes API, not so much as within the app, the connections within the app itself. So.
Great. So that was it for the audience questions. There are a few questions that I want to ask, but if there's any more from the audience, we do have a bit of time for those as well. So keep them coming. Thank you so much for them so far. So, question: what kind of certificate management is required to do this?
Okay. It's very simple. You have to provide the trust root and an issuer that is derived from it. And you just have to make sure that you rotate that whenever it's needed. There's a Linkerd check command that will warn you whenever that expiration date is close. Usually what people in production do is to provide this through external specific tools like Cert Manager that I also mentioned that will generate and rotate the certificates automatically. And so it's very easy to integrate that with Linkerd. And there are also Cert Manager has also some optional hooks that you can also use in Linkerd. So yeah, I think Cert Manager for now is the best practice regarding certificate management.
Great, perfect. So how does mTLS compare to a lower layer encryption such as WireGuard?
Yeah, the issue with lower layer encryption is that since you don't have access to higher up the stack stuff, then your only identity that you have available is the IP. So that doesn't give you much flexibility in what you can do and the rules that you can express. I think it would be hard for, in the example that we showed, securing up just a single namespace because you don't have a way to express which workloads you're interested in besides their IP, which is something that can change. So I would recommend that you use tools that are higher up the stack as possible so you can better express things.
Great. And then there was another audience question. Notice that on one of the logs, the protocol says HTTP and not HTTPS. So is it possible to upgrade the connection to HTTPS for production?
Yeah, that's interesting. Emoji Voto indeed does use HTTP by default, but you have mTLS on top of that, so the connections are still encrypted. There's HTTP on the lower layer, but that's wrapped around mTLS, so it doesn't matter if the lower layer is not encrypted itself. We don't do besides that, we don't touch what goes under the mTLS layer. You could, so we don't do any kind of upgrade in that sense. You could have your connections be TLS from the get-go, and Linkerd will just let them through. Well, it will wrap them as well mTLS, so it can provide the workload identity, but it works just fine as if they were not encrypted.
Great. We have a few minutes left, so final call for questions from the audience and final question from me. So how do I ensure that I always know which communication is mLTS and which isn't?
Okay, we showed that a little bit with both a command in the console. There's this tab that shows you a sample of all the connections going through some specific resource, and that will tell you whether they're mTLS or not. You also have the dashboard, the Linkerd dashboard, that will show you some green checks for a given resource, the incoming and the outgoing connections, whether they're encrypted or not. And if you set, like we saw, we set some policies to allow incoming connection from the namespace. We only allowed connections that have specific identities, and that by itself implies that they have to be mTLS. If they're not, their connections would be denied.
Great. Thank you so much. No new questions from the audience, but we answered quite a many already, so no worries. We got through them all. But yeah, time to wrap up then. You can obviously always continue the discussion in the CNCF Slack channel for Cloud Native Live. everyone. So tune in there if you want to chat with everyone about these topics. So, just to wrap things up, thanks everyone for joining the latest episode of Cloud Native Live. It was a great to have a session about locking down your cluster. Really love the audience interaction and the questions from the audience. Thank you so much. And as always, we bring you the latest Cloud Native code every Wednesday. Next week, we will be having a break, but we will be back in 2 weeks with another great session. So stay tuned for that. Thanks for joining us today and see you in 2 weeks.
Thank you very much, Honey.